would like to welcome the first presenter, Dr. Nitin Muttil. Dr. Nitin Muttil is the leader of the Water Resources Research Group in the College of Engineering and Science at Victoria University. His research expertise is in the area of urban drainage modeling and flood control, water-sensitive urban design, and the impacts of climate change on water resources. Dr. Nitin will be presenting on developing a stormwater harvesting system at Victoria University's Sunshine campus to complement an existing harvesting scheme.
Good morning, everyone. The topic in which I'm going to present originally was on the Sunshine campus, and now it includes also the Foodscape Park campus. So there's a bit of change, and in fact I'm going to focus more on the Foodscape Park campus. And as my name introduced, my name is Nitin Muttil. I work at Victoria University, and I teach into water resources subjects. I have been working, my core background is in civil engineering, and I've been working at Victoria University for almost 15 years now. And since the last 2 years, we have been thinking on why stormwater, a huge quantity of stormwater which runs off our campuses, and why that has not been harvested. And we had some students working on projects, and I've been discussing with colleagues at Greater Western Water, and Darren Coughlin was also part of this project in all the discussions, and he is one of the authors, and he's also sitting here. Now this is the outline of the project. I'm going to talk about what were the drivers, why we got into this project, what was the idea behind. And then I'm going to talk about both these with a focus on Foodscape Park. And I'll briefly, depending on time, mention about the stormwater harvesting system at the Sunshine campus. Okay. Now I'm going to talk about the key drivers, the motivating factors why we felt this project was important, and why we got into it. Now, one of the first things which I'm sure is a concern for all of us is the increase in population and the associated problems. And then, you know, the other important thing with stormwater harvesting is it's connected with its utilization, which is greening. And in these two projects at our two campuses, one of the main motivators is to have green surroundings, and the stormwater can be used for that. And Darren Coughlin, of course, championing greening the West was also a motivating factor behind this. And then the water conservation, you know, we all, especially those of us who have gone through the drought, you know, the millennium drought, and collaboration was one of them too. The other important factor which I have not mentioned here, it comes later, but I will mention now in the beginning itself, is at the Foodscape Park campus, we got a new hospital coming up, which is just across the road, opposite our campus. And the visitors and patients coming at the hospital will be directed to the Foodscape Park. And from that point of view, if we have a park which is green, which is inviting, is of big value. So that was another driving factor. Okay, so that's, you could say, the overall goal. I'm not going to read everything, but we all know that we are looking at green infrastructure, we are looking at blue infrastructure, and it's all water enabled, because if you don't have water, or if you don't have enough water, then green and blue stormwater harvesting in wetlands and don't work. And then of course we are looking at the health and the livability and all those aspects also. And from the health and livability aspects, this report, which was published a couple of years back by WASA, Water Services Association of Australia, which talks about blue plus green is equal to livability. So that's exactly what we are trying to do with this project, to enhance the livability with blue infrastructure, which further leads to greening. Okay, I won't spend time on this one. We all know what's green infrastructure, what's blue infrastructure. And in these two projects which I'm presenting, our focus of course is on stormwater harvesting. Yes, so the first case study, and most of my time I will spend on this one, and as I said, possibly depending on time, on the Sunshine campus also. So this project is looking at stormwater harvesting from our campus, the Foodscape Park campus, plus the catchment surrounding the campus, with the goal of irrigating the Foodscape Park. And that's a Google Earth image of our campus, which is there in the north. And that's the park. And that's the new hospital, which is under construction. It's come up very, very fast in the last 6 months, 10 months and so on. Over the break, I think I was away from Melbourne before December last year. And by the time I came back in 2-3 months, the superstructure was quite well coming up. So the new hospital is there. And again, repeating, what are we trying to do? We are trying to harvest the stormwater which runs off our campus, plus the surrounding catchments, store it somewhere at the Foodscape Park, and then that stored stormwater is used to irrigate the park. And as I just mentioned, that's the new hospital. It's an artist's imagination, but very soon you'll see something like that already constructed. So what we see is on the left-hand side, this is the new hospital that's coming up. And on the left-hand side, the buildings are our campus, the Foodscape Park campus. And in case anybody's not familiar, it's the Ballarat Road which goes in between. And if you drive straight down 90 kilometers, we reach Ballarat. In case somebody is not familiar. And this is again an artist's impression, seen from the other side. So you've got the hospital on the right-hand side, you've got the campus on the left-hand side, and there's a pedestrian overbridge which would direct visitors and patients from the hospital through the campus into Foodscape Park. And the construction for that overbridge, the pedestrian overbridge, has already started. I believe in the next few months it will be complete. And from that point of view, having a green and inviting Foodscape Park is important. And that's the goal of what we are trying to do with this proposed project. That's a picture taken a couple of days back of the construction of the hospital, seen from the campus across the road. Okay. Now, our campus, as you will see in the next slide, has got about 10 different buildings. And this analysis was done of the area of each of the buildings and what's the total area of the roof plus pavements. And we've got the area for the roof plus pavements from where the stormwater will run off, taken. And that's added. And a quick analysis was done with the total area, the paved area and the runoff area. And the total rainfall was assumed, a runoff coefficient was assumed, and then approximately we would expect stormwater that could be captured in the range of 14 to 15 million liters annually from our campus. This is just from the Foodscape Park campus. And we got some data from Maribyrnong Council, and this indicates the water used by the council for irrigating the Footscray Park. And we got in fact 10 years of data from them, and that's the last, not last, but we got 10 years of data, the last year being this one here. And what we see on an average, the amount of water which is used for irrigating the Footscray Park is in the range of 24 to 25 millimeters on an average annually, based on 10 years of data. And the cost over the 10-year period for the council to irrigate the Footscray Park was $622,000. So on an average, 24 to 25 million liters, and that's costing about $62,000 annually. That's for the council, so this data is coming from the council. And now some of our students, as part of their final year capstone project, have done some analysis, and this table indicates the surrounding catchments from which the runoff comes into the Footscray Park, and it falls into a pit, and then from there it in fact drains into the river, the Maribyrnong River. And this analysis indicates the different catchments, the area and the runoff coefficient. So the students had done quite a bit of detailed analysis, and what they found was, based on this, and in fact there are two stormwater drainage pipes which comes into the Footscray Park. One is run by Melbourne Water and the other one by the council. And the total volume of runoff from the surrounding catchments, which can be harvested but it is not, it drains into the river, is in the tune of 126 million liters annually. So the project which we are proposing, and this 126 million liters is without the stormwater which runs off from our campus. So if you add 126 plus another 14 million liters, so that's about 140 million liters of stormwater which runs off the campus plus the surrounding catchments, which as of now is drained into the river. So you can imagine the amount of stormwater which is available, and what we require for harvesting, for irrigating the Footscray Park is just a fraction, 1/4 or 1/5 of that. So if we can even harvest and capture a part of that stormwater which runs into the river, the irrigation of the park can be done. Now, the students who worked on this, in the end I'm going to acknowledge them, and they have done a very good job with the complete design of the irrigation system for stormwater harvesting. And this included various treatment options. I've written them, so it's a combination of treatments, and there were 2 or 3 designs. So these different treatment options and the storage options are not part of one design. So we have 2 sets of students, and so there are in fact 2 designs there. So I have not separated them out, I have just put it together. So the treatment options included GPTs and infiltration systems. We have UV system, and in one design the students also considered wetlands as the treatment option. Plus in the wetland design they have on surface storage, storage basins, and in another design they also considered underground storage of the stormwater. And that's a picture of the option which includes the wetlands plus the surface storage. And I don't have a picture for the other design, which was the underground storage one, but that's one of the designs which the students came up with. And this is the irrigation system. It's not complete, of course. So the irrigation was done for the whole park in 3 parts. So the park was divided into A, B, and C. So part A was the recreational, the ground there, the main footscape park, plus the two overs, so A, B, and C. And the students have designed a sprinkler system. And I've just put in the sprinkler system for irrigating part A of the park. And they had similar designs for B and C. So that was the irrigation of the park using sprinkler systems. Okay, so I think I'm doing good with the time, and I can get into the second stormwater system, which is at our Sunshine campus. And so this is the second one, which I'm going to talk about. And this is the Sunshine campus, Victoria University Sunshine campus. And this is the road which is going down in the south here, is Ballards Road. And just across the campus on the north here, there's a street here, I'm not sure if you can see, but that street is called Phoenix Street. And just across the Phoenix Street, we have the park, which is called Dempster Park. And then on north of the Dempster Park, there's a school, and that's called the Harvester Technical College, which is right here in the north. So the Dempster Park is, of course it's a park, but the school also has a play area, playground, which is for the school, and that's this one. And as some of you may know, the Dempster Park has got a stormwater harvesting system, which was, it was led by the council, Bringback City Council, and supported by Greater Western Water. And as you may know, Greater Western Water has or had this stormwater partnership fund, and as part of that fund, they have partly funded this stormwater harvesting system at Dempster Park. And this included an underground storage system. I think if I remember correctly, that's a Frankishy one, a Frankishy underground storage system. And the size of that tank was 1.2 million liters. Now, this water which is currently being used to irrigate the park, as you would see in the next slide, it makes sure that the Dempster Park is lush and green. As you can see here, it's not very evident in this picture, but if we had better lighting, you could see that this is an image taken from Google Earth. And the Dempster Park is greener, but you look at the surrounding areas, including the play area with the school, the college, Harvester College, you'll see that this is still brownish in color. And in fact, we had visited the site, and the next slide has two pictures taken from that red dot, one of the Dempster Park and the other of the ground, which is the Harvester College playground. And these two pictures will indicate a contrasting picture. The Dempster Park is green, as you can see, but the Harvester College ground obviously is in need of proper irrigation very badly. Therefore, this project, what we are proposing is to harvest the stormwater which runs off from VU Sunshine campus, store it underground possibly. There are car parks, so there's enough underground storage possible there, under the car parks. And then that stored stormwater which from the campus is used to supplement or complement the already existing stormwater system for Dempster Park. So that's this whole project for the Sunshine campus, which I am talking about. Yes. Okay. Okay, I think I don't have details for this one. I was thinking that I would be running out of time. It's great I have not, but I think so. This is in fact the concluding right, where we are talking that for this campus, where we are trying to complement the stormwater harvesting system at the Dempster Park, and it will also complement Brisbane Council's Dempster Park Oasis. I think it's in the planning or conceptual stage now. So this proposed project to harvest stormwater from the BU campus would contribute to the council's Dempster Park Oasis also. Okay. Now, so that's my last slide, and as we have seen just now, there's a huge potential for stormwater harvesting from both the campuses, especially from, as we saw in more detail, the Footscray Park campus. The total stormwater potential for capture is around 125 million liters annually, and out of that, and as of now, that huge amount of stormwater is drained into the river. So we are trying to capture, if not all, a part of that. And as we saw, the irrigation of the Footscray Park would require only a fraction, 1/5 of that stormwater. So if we can capture about 25 million liters out of the 125 which runs off, that would be enough to irrigate the Footscray Park. And then of course it would contribute to the various breathing initiatives, contribute to breathing the waste, contribute to DCA's integrated water management plan, and improve the health and livability and so on. Okay, now I would like to acknowledge a few people for the work which I just presented. Professor Stephen Gray, he is the director of our research institute at Victoria University, acknowledging the support provided for this project by Stephen. And I would like to acknowledge Peter Lecter. He was rather, in fact he's retired now. And Peter was part of this project. We had two groups of students here. So I acknowledge the students who have contributed to this work. And one of the groups was supervised by Peter. So acknowledging Peter's wonderful work in this project. And of course I would like to again acknowledge and thank Darren for his contribution to this, and also to Tom Stefano. Tom's also there to give his inputs to this project. And in fact, in one of our student meetings, we had Stephen Hurd from Frankishi. So he had presented Frankishi's stormwater treatment storage systems to our students also. And that was also part of the design which the students had done. So acknowledging Stephen's coming to our group meeting and presenting Frankishi's storage systems also. In fact, that's a picture taken on that day where we had the students here, one of the two groups here who worked on this project, and of course we had Darren and Tom also for this project. And with that, I think I will conclude my talk. Thank you very much. Any questions? Comments, please.
That's the
Yes.
Steve Dagger of Urban Water Solutions. Just wondering if you could elaborate more on the treatment side of things, and sort of in the context of Dempster Park, whether how that is, have you done any analysis on how that's working, and are there anything you do differently with the new, the new systems?
Yeah, sure. Now in the Dempster Park, the existing stormwater harvesting system, I don't have a picture of the existing system there, but when it was under construction, as you can see. So that has got rain gardens and ultraviolet treatment of the stormwater there. And I think maybe I'll just talk about the plan for the Footscray Park, and if Tom or Darren want to talk about what's happening there, because I think they are much more familiar with the treatment system there at the Dempster Park one. But at our Footscray Park, I'm going to just come back to the previous slides. And as I said, with the treatments, we had initially with the start, we had the gross pollutant traps to litter, as we saw in the keynote by Cheryl, that the litter is a big issue. So we have gross pollutant traps, and then we are looking at, in one of the designs, we have wetlands. The water goes through the wetland system, and that gets, so not sure if you can read, but the water comes into the wetland system somewhere there, and we have the GPTs there. It gets into the wetland, goes through that, and then it's stored in the surface storage there, from where it's pumped into the irrigation system. So that's one of the designs which the students had come up with. And the other one, the other system which they had, included underground storage. And the treatment was with filter systems. So these are commercially available filtration systems, plus UV filtration. So those are the two plans which the students had come up with. I don't know if Tom or Darren would like to mention briefly about Dempster Park, if you want.
Yeah, Tom's definitely great at Western Water. Dempster Park is now fully operational. It includes your traditional GPT pump station, below ground storage in this instance, and a irrigation pump kiosk, compact pump kiosk. I think the emphasis at Dempster Park was to address sediment capture, and that's one of the things that, from my point of view, GWW's point of view, is that we don't have enough credibility in equipment suppliers to supply purposeful equipment. I'm sure they've all done their research and they've all done their testing, but I made a decision at Dempster Park that I was going to install a sediment capture device. So the sediment capture device augments the GPT. So, and at Dempster Park we also had a rain garden. The rain garden doesn't work, but that's another matter. But I really want to acknowledge the work that Dr. Linton is doing, because it nurtures future environmental engineers for this industry. And we need to be able to utilise the academia to help us design and develop better stormwater harvesting schemes. And one of the things that I think the university can help us as practitioners is to be able to performance test, performance ride these equipment. And I'm quite keen to work with the university to develop test programs. And it's not just for Dempster Park, it's for the operation and maintenance aspects later on with the stormwater harvesting scheme across various applications, various sites, so that if there is a change in the performance over time, then that translates to increased operation and maintenance costs. And that. So we need to understand all of that. So I think that whilst we can select material or select equipment, it's really important to understand, well, how can we better tune them, how can we better operate and maintain them so that we get the maximum